Today we'll review questions that refer to determining the 6 trig ratio for an angle, determining all trig ratios when you're given a coordinate of a point on the terminal arm, and determining all trig ratios for angle measures given one trig ratio. So we'll cover a few questions that will meet these 3 goals. And most of the questions are taken from your textbook. Just a background, we will be utilizing our knowledge of the unit circle and the reference triangles, meaning the 45 degrees, and the 60, 30 triangle. Okay. And just remember, we did sketches of those on the unit circle. There's a visual representation of all of it. Also, we'll be looking at the CAS rule. Just remember that the CAS rule is an acronym to remember the quadrants, the 4 quadrants, and where in these 4 quadrants the trig ratios are positive or negative. So in quadrant 4, all of the cosine and secant theta are positive. Only cos and secant are positive. Quadrant 1, all of the trig ratios are positive. Sine, cosine, tangent, cotangent, cosecant, and secant are all positive here. Quadrant 2, only the sine and its reciprocal cosecant are positive. In quadrant 3, only the tan, cotangent are positive. So we utilizing these facts. Also, we'll be making use of the trig ratios and its reciprocal. Okay, so we'll keep those in mind. So we'll be utilizing all of these, referring to each one. First question I want to look at is determining the exact values of the 6 trig ratios when you're given for an angle. So you're given an angle and you're asked to find the 6 trig ratios. Now, remember, your 6 trig ratios are cosine, and using the circle, when any angle in a standard position with terminal point pxy on the radius r. So here we have it here. I'll just zoom out. So here we have the circle, and here is your terminal point on the circle. Then cosine is x over r, and secant is r over x, etc. So we'll be utilizing these trig ratios throughout. So let's go to the first question. Zoom in here. There are 2 parts to it. Part 1, determine the exact values of the 6 trig ratios for negative 420 degrees. The first thing you want to do, you do a sketch. And here I have a circle. I'm going to sketch of a circle here. And x and y with the center at 0, 0. Right? Now, here we have negative 420. So I start, remember, negative going clockwise direction. So when you for 360 and start 360 degrees from going around here, 1, so that's 360, and then you continue to 420. So your reference angle, in this case, it's 60 degrees. So terminal point is here, pxy. The reference angle is 60 degrees. Okay, so first step, you want to do a sketch negative 420 degrees in standard position. Then determine the coordinates of the point pxy. So we want to find this coordinate here. Okay. So the measure of the coterminal here is negative 60. Right? So the measure of the coterminal, negative 60 degrees, because we're going clockwise, so it's negative 60 degrees, which is 360 degrees minus 420, which is negative 60 degrees. But this terminal arm here lies in quadrant 4. So we have quadrant 4 here. Okay. Now, in quadrant 4, what is positive in quadrant 4? Cosine, right? Remember your CAS rule back here? So we are in quadrant 4. This terminal arm is in quadrant 4. So the cosine and secant are positive. Okay. So we can see here the terminal arm lies in quadrant 4. Where cosine, the cosine ratio is positive. So we can say cosine ratio is positive. And so we have the cosine is positive, and the sine and tangents are negative, right? So sine and tangent are negative. And we know that from our CAS rule, right? The reference angle now, it's kind of up here, so you can see a circle here. So the reference, let's put 2 here. The reference angle is equal to 60 degrees. So now let's look at what we have. So cos of 60 degrees is equal to, now this is where you're going to look at your reference triangle, or in your booklet, you can look at your reference angle, and where you have 60 degrees. I'm referring to this one here, but I'm not going to use this, but use if you want to refer to it. I'll use a much more compact one. So here we have cos 60 degrees is equal to a half. So now we have a half. Now, by the way, you can use your calculator, but we're not using our calculator here, right? We're using our reference triangle. Okay. Now, cos 60 degrees is equal to half. Right. Now, because sine is negative here, so cos is positive, so we can say that from this now, we know cos, this is a reference angle, so we can conclude, if we go to negative here, right, cos negative 420 degrees is also a half. So cos negative 420 degrees will be a half. If this is a reference triangle, it's still here. Okay. If we were to say secant now, which is the reciprocal of cos, we can say secant negative 420 is also a half. So here we have our, now the same thing would apply for, now we have sine. So we have sine, now because we have negative 60 degrees, we can write this as negative sine. Now, because sine here is negative, we go to our sine. So sine 60 degrees is root 3 over 2. So more reference triangle. So sine 60 degrees, we can say that. So now because it's in quadrant 4, it's negative. So negative sine 60 degrees is equal to negative root 3 over 2. Sine is important because they're in quadrant 4. And quadrant 4 tells me that the sine is, and also the tangent will be negative. So we have sine. So now we can write this as now sine negative 420 degrees is equal to negative root 3 over 2. Now we have cosecant negative 420 degrees is exactly as we have, oh no, that would be the reverse, right? No, 2 over 3, so it would be exactly. This is a reciprocal. Oops. This would be 2, negative 2 over root 3, because cosecant is reciprocal. Now this should be, oh, this is wrong. It should be 2. Okay. Apologies about that. Getting too excited here. Now we've done a cosecant. Now we go to a tangent. So tan negative 420. Now, if we go back to our trig ratio, tan 60 degrees is root 3. But this would be negative because tan is negative here. Negative root 3. And cotan neg 420 would be equal to negative, because remember this is 1 here. It's a reciprocal, negative 1 over root 3. So there we have our trig ratios. So cos, secant, sine, cosecant, tangent, and cotangent. Now, part B, determine the 6 values. We can use, or you have to use a calculator for that part, and I'll just won't go through that. I'll let you try that on your own. So all what we have to do, make sure you're in mode is in degrees. Let's check, make sure in degrees mode. And for example, we have cos of 586. We press your cos of 586. Let's give us negative 69 approximately, etc. Now, to find the secant of that, it'd be 1 over cos, etc. So I'll let you try that out using your calculator. Okay, that's the first one I'd like to cover. Now, there are a couple of related questions in your exercises. And let's go on to, let's see where, oh, here they are. Okay. This is from your textbook, question 7. Determine the exact value of the 6 trig ratios. here you can do another sketch, right? You will do a, oops, not a very good start here. So here we'll have a little sketch a circle. Now we're going, because it's positive, we're going counterclockwise. So if you will start from here, go around here, this is 180, 360. Now we have to go another 120. So the way to find, so let's find a coterminal. That was what I'm doing, coterminal arm or angle. Just do angle. Remember, it's 480 degrees minus 360 degrees, which is 120 degrees. So I need to go back now. This is 360 here. So I need to go 120, which is to be around here. So now this becomes my terminal arm, so PXY here. Now this is 120, so therefore this would be 60 degrees. So my coterminal arm is 120 degrees, but my reference angle is 60 degrees. So coterminal 120, right? So the reference angle is equal to 60 degrees because it's from 180 here minus 120, which is 180 degrees minus 120, which is 60 degrees. Now we'll use your, now in this quadrant here, quadrant 2, in quadrant 2, sine theta is positive, right? Because we know in that quadrant is positive. And we also know that the reciprocal of it is also positive, which is cosecant theta is also positive. The other ones, secant, cos, tangents, etc., is negative. They're negative because that's what Cass rule here, right? So I say refer to your Cass rule repeatedly because it helps you to make your work simpler. Now, so we need to find a reference angle. So we're going to look at, so sine 60 degrees is equal to, and we'll go to our wonderful, which we just did, by the way. Almost similar question. Okay, maybe I should have chosen a different question. Is root 3 over 2. So sine is root 3 over 2. So now we have, so sine 120 degrees is root 3 over 2. And cosecant 120 degrees, or I should say 480 degrees, I should say. Oops. 480 degrees, because this is what we're looking at here. It's a coterminal arm. Is a reverse. Now it's root 2 over, or just say the reciprocal. Now we look at cos 480 degrees, which is the reference angle, which is cos 60 degrees. Go to, which is a half. Okay, so cos 60 degrees, which is equal to, but because it's in quadrant 2, it's negative. Right? In quadrant 2, it's negative. So now we have this a negative a half. The reciprocal is secant 480 degrees. Well, now it becomes negative 2 over 1, which is negative 2. I'll erase this here so I can get some space here to now do my tangent. So now tan 60 degrees, which is root 3. Okay. Now, but tan 480 degrees will be negative, right? Because it's negative in quadrant 2. And cotangent 480 degrees would be 1, negative 1 over root 3. This is 1. So there you have your 6 trig ratios. The next one is 855 degrees. So a coterminal angle, if you were to do a series of concentric circles, will be 225 degrees. Okay. So I'll let you try that one. So, and I'll just write the results here. We have the coterminal is 225 degrees, but the reference would be, because if your coterminal is 225, which is 180, so 225 will be approximately here. Right. So the reference angle here would be 225 minus 180 degrees, which will give us what? 225 minus 180, 45 degrees. So the reference angle, here we have, pardon me, our coterminal is 225. So if we say coterminal is 225 degrees, but the reference angle is equal to 225 minus 180 degrees, which gives me 45 degrees. So now, in this quadrant here, remember the Katz rule, tangent is positive here only. The sine and cosine, they're all negative. Okay, so we can put here sine 45 degrees. We go to our reference triangle. Sine 45 degrees is 1 over 2, root 2. So it's 1 or negative 1 over root 2. Okay. So now sine negative, terminal would be negative. So sine negative 855 is equal to negative 1 over root 2, and cosecant negative 855 is equal to, the reciprocal will be negative root 2 over 1. Now, cos 45 degrees, which is the same as sine, will give me 1, be negative 1 over root 2, because it is in quadrant 3. So we have here cos negative 855 is equal to negative 1 over root 2, and secant negative 855 is equal to negative 1 over root 2. And the last now, tangent. So tan theta now is positive. So tan 45 degrees, oh, here, 45 degrees we're dealing here. Remember, that's equal to 1. Okay. So tan negative 855 degrees is equal to 1, and cotan negative 855 is also equal to 1. Is 1 over 1 is 1. So those are a couple of questions you don't mind trying out. I could give you the solution, full solution to it. Okay, let's go on to another question, which is here you, let's just check your understanding question number 3. And you can see a common theme among these questions, right? You're constantly using your trig ratios to reinforce what you already know, but also you're repeating a lot of these questions. So let's look at this one here. First thing we want to do is to do a sketch. Here I have a sketch, and I've done it already here. And the point here is -1, -4. So it's in quadrant 3. So in this quadrant, we'll know right away that using our CAST rule, CAST, that only tangent is positive here. So they want us to find the exact 6 trig ratios. Now we know x, we know y, but we need to find r. Okay, so this is going to be our x value here coming down is -4, or y value here is -1. So this point here is -1, -4. So we let the distance between the origin and the terminal arm here on the circle, right, be r. We let it be r. Okay. So first thing we sketch our diagram, right? And let's call this the origin O and this P. Let OP be R, right? We let it be R for the sake of argument. You can give it whatever letter. The reason for that, because we can use a wonderful x squared plus y squared equal r squared. We know that x is equal to is given. So given x equal to -1, y is equal to -4, we need to find r. Once we find r, then we can go to our 6 ratios here for any angle in centered position, terminal pxy on the radius r. So here we have our point P on the terminal, on the circle PR. Once we know our x, y, and the r, oops, there we go. We need to know x, y, and the r. We can substitute into the ratios here to find our 6 trig ratios. So we need to find r. So we have x here. So we're going to substitute the values. So substitute x equals 1, -1 actually here, and y is equal to -4. Right? So we have -1 square plus -4 square is equal to r squared. So we have 1 plus 16 is equal to r squared. So we have 17 is equal to r squared. So we said r is equal to plus or minus the square root of 17. But remember, we are in quadrant 4. So sine will be negative and cosine will be negative here. That's where we will use our negatives. And it will make sense because you will see your x values here. What I mean by that. Let's look at the first of all, let's start with trig ratio. Sine theta, we know that's y over r. The sine is the opposite, right, over the hypotenuse. If you look at the Pythagorean theorem, the opposite here is x, right? So -1. So we can say that's -1, and r, right? In this case, we'll make that root 17. We can make it -7. So sine theta is -1 over root 17. Now, secant, right? Cosecant, I should say. Cosecant theta is also negative because it's the reciprocal of sine, which is r over y. So what's so r over r is equal to 17. Now y is already -4, so we put -4 here. Make sure you have your signs. Okay. Oh, let me be y. Cosecant is, now y is what? -4. Oops, sorry, is a -4 here. Oh. Now, transferring my data correctly here. So we have cos theta now. We have x over r. Now, make sure I get this right. So x over r, x is -1 now, and r is root 17. So we have -1 over root 17, and now we have secant theta, which now was r over x, or r is root 17, put a negative there, and our x is -4. X is 1. Okay, let's just flip of that. The last one is root 10 theta, which we know it's y over x, and here it worked out because it's positive in this quadrant here, quadrant 3. So quadrant 3 will give us -4 over -1, which will be equal to, so write that here, -4 over -1 plus 4. And cotangent is x over y, and this will give us -1 over -4, which is a quarter. So there are our 6 trig ratios. Okay, you probably would like to try out question 8, which is very much alike the question we just did here. Follow the same pattern. Right? But also, I wouldn't mind if you were to try this question. I'll post the answers on the blog for those of you who would like to try it out. But meanwhile, if you go to your this is on page 476 in your textbook. And try to complete these using your reference triangles and the ones you have here. I think I've posted this on the blog, the full solution, but try to do it without looking at the blog answer. But just look at the first one here. We have sine. Now this is your unit circle here. And the x at the point 1, 0 is your cosinus sine. So cos 0 degrees is equal to 1, and sine 0 degrees is 0. Tan is 0, because tan is a sine over the cos, right? 0 over 1. So 0 over 1 is sine over cos. Now cosecant, right, which is the reciprocal of sine, will not work because it becomes you're dividing by 0. So that's why it's undefined here. So it's undefined. It's also undefined for cotangent because you cannot divide by 0. The rest now, you can use your trig ratios here. And Just remember when you're looking at the cosecant is or the secant, you're referred to as the as the reciprocal. Okay, so you can look at the 30 degrees, like sine 30 degrees is a half. Do that here. Cos 30 degrees. Look back at the chart here. Cos. There we go. Set that a little bit. You may refer to your reference triangle a lot, but that's okay for now. But later on, you should be able to memorize this reference triangle, and it become part of your thinking. But I'm just showing you how I'm arriving at these numbers here. Okay, so if you continue the trend here, cos of 30 degrees. Let's zoom in here a little bit. Cos of 30 degrees will give you root 3 over 2. Tan of 30 degrees is 1 over root 3. And I'm just looking at my reference triangle here, right? Now, cosecant now is the reciprocal of sine, will give me 2. Secant is the reciprocal of cos, will give me 2 over root 3. And cotangent is the reciprocal of tangent, which is root 3 over 1, root 3. Once you've done up to the first, 1, 2, 3, 4, 5, the rest is all repetition. So let's go through sine 45 degrees is 1 over root 2. By the way, we'll repeat this when we get into the section on radians. Right now, we are working in degrees. Same as root 2. Tangent is 1. Reciprocal of this is root 2. Root 2. And it's still 1 here. 60 degrees, and I'm going back to my last one here. 60 degrees, we have root 3 over 2. And we have 1/2. Tangent is root 3, 60 degrees. You have 2 over root 3. Now there's a reciprocal. So reciprocal here, you have 2. And the reciprocal of this is 1 there. So it's 1 over root 3. Now the last one I like to do now is 90 degrees. And look back here. This is your cos, and this is your sine. So cos of 90 degrees, or such as sine of 90 degrees is equal to 1. So sine of 90 degrees is 1. Cos of 90 degrees is 0. Right. Now tangent, right? Remember, tangent is sine over cos. Now, which is sine over cos, which is 1 over 0. This is undefined. You cannot divide by 0. So that's why this will be undefined. Okay. Next, we go to cosecant, which is the reciprocal of sine, b1. Secant, which is the reciprocal of cos. Now, that will be undefined, right? Reciprocal, because you cannot divide by 0, right? 0 divided by itself will be, so this is undefined here. Now, cotangent will be different now, because now we have 0 divided by 1, which is 0. Now, the rest is all, you're going to see the pattern now continues right now, 120 degrees, right, of which will be the same as 60 degrees, right? Okay, this would be, the reference would be 60 degrees here. 135 degrees, the reference would be same as 45 degrees. And this would be the same as 30 degrees, right? Because if you were to look at 150 degrees would be here. This would be 150. Oops. This would be 30 degrees here. same as 135. So the reference would be 30 degrees. So it will be a repetition of all of it. This would be, now, at this point here, it's a repetition of 0 degrees, right? So go back to 180. Okay. So, but in this case here, we're looking at the cos as negative and your sine is 0. So cos 180 is -1 and sine 180 degrees. So here we have sine, oh, here we go, 180 degrees would be 0. -1 is cos. Tangent would be sine over cos, which is 0. So we have 0 over -1 is 0. Now, cosecant is the inverse. You cannot divide by 0 in this case here, right? So this will be undefined. Let's put undefined here. This will be -1, and also this will be undefined. Cotangent, you cannot divide by 0. So try and complete this and test yourself, and then compare it with the answers on the blog. I want to try do one other example, and that will be the end of lesson 6.1. We're going on to lesson 6.3, looking at radians. So let's look at one last question, which is question 10 in your booklet. In this question here, you said for each trig ratio, determine the exact value of the 5 trig ratios for theta given the domain of cos is 1/√2. Now, we restrict it to between 0 and 180 degrees. So if I were to do a sketch of this up here now, so we remember a cast rule, cos theta, right? Cos theta would be what? Here we have 1/√2. Now we have to find the inverse. So cos theta 1/√2. What is the angle? Right now we do not know the angle for that. So we have to refer to our reference triangle to find what angle is cos 1/√2. So we go to 1/√10. Here are our possibilities here. So we have √3/2. Okay, cos a half. No, we're not looking at that. Cos of 30 degrees. No. But look at cos 45 degrees is 1/2. So we need a reference triangle for this question here. So we can say cos theta equal 1/2. So cos 45 degrees, right? So for the given domain, so theta is equal to 45 degrees. Okay, so we know it's going to be, now cos positive could be adding here, 45 degrees, or 45 degrees. Okay, this is positive. All right. So cos theta is equal to, given us 1/√2, and secant is equal to √2, right? So we're looking at 45 degrees now. Sine theta, or 45 degrees, is the same as cos, right? 1/√2. And cosecant theta is also which is a reciprocal of sine 45 degrees, would be root 2. Tan 45 degrees, I should put here theta, is equal to 1, and cotan theta is equal to 1. So you're given the domain, you're given the value, but not the angle. The ratio you're given, the 1 over, and that's where you need your reference triangle. 1 over root 2 is 45 degrees. So cosine is adjacent of a hypotenuse, 45 degrees. Next, we look at cotan. Look at the next one here. Cotan theta of negative 3. So this is where you go back to our reference triangle. Now, in this case, they tell you the angle is between 90 and 270. So we're not dealing with, so we're not looking at quadrant 1 or quadrant 4. We're looking at quadrant 3 and 4. Right. So looking at this, right, we get cotan is 150 degrees because if you look at half, right, so cotan of which is going to give us 60 degrees, right? So cotan of 60 degrees is, because it's in that quadrant, right? It would be equal to 150 degrees. So it's in here. Oops, there we go. 150 degrees. I'll just do a sketch over here. Maybe I'll get a straight line here. So 150 degrees, no, 150 degrees would be, so be 150 degrees up here. This will be cotan, which is 30 degrees, right? So we have 30 degrees here, or we extended it further, or 330 degrees. So reference angle is 30 degrees because cotan theta of negative 1/3, if you go back here, this would be cotan is equal to root 3. But since we are going to negative, it will be negative 1/3. So this is a reference to 30 degrees angle here. So cotan, if you look at here, so cotan of 30 degrees is equal to negative square root of 3. So tan theta, right, which is 30 degrees here, is 1 over root 3. Sine theta, which is 30 degrees, will be equal to a half. And cosecant theta, we're looking at 30 degrees here, is equal to the reciprocal. This would be 2. That's in this quadrant here. Okay. Then we have cos theta, which is 45 degrees. Oh, so 30 degrees, not 45. 30 degrees. And that would give us negative root 3 over 2 because it is negative in this quadrant here. And secant theta would be negative 2 over root 3. make sure you got this all right here. So we have cotan 30 degrees is negative reference angle 30 degrees. So we have cot theta is negative √3, which is given here. So tangent theta will be, should be negative here. Negative 1/3, because it's negative in this quadrant here. We're dealing with quadrant 2, right? Negative in this quadrant. It will be positive in here. Then sine 30 degrees is a half, quadrant here, and cosecant is 2. Cos 30 degrees is negative 3/2, so cos is negative in quadrant 2. So we're just dealing with quadrant 2 right now. So that's why the tangent here, I had to switch it over to negative. So let's rewrite this a little bit clearer. So cotan of 30 degrees is equal to negative √3. So we can say cot theta is negative √3. Now, since we are working in quadrant 2, cotangent is negative as well as tangent is negative. Now, if we go to the reference when it's 330 degrees, now that will switch over to negative. 330 degrees would be over here, sorry. This is, okay. This would be 180 plus 30. That will give us 210 degrees. Okay, so those are your 5 trig ratios. So we have 1, 2, 3, 4, 5. So we can highlight those. For question 11, it's a similar question. You have sine is negative 1/2. So you'll find what the angle for negative 1/2, and you'll find it's 30 degrees. Okay, so sine 30 degrees is equal to 1/2. But now we're dealing with an angle that's negative. So if you look at our CAS rule, so we're looking at angles between in quadrant 3 and quadrant 4. Okay. So the sine now lies in quadrant 3, quadrant 4. Okay, let you try that one. I'll post the answers on the blog.